Hello, welcome to Mr. Johnson Math and Science class. How are you doing today? Hope you're having a nice time. Okay, in this class, our mission is to rejuvenate the passion for academic excellence. And here is an email, and we also have a digit you can use to reach out to us. You can also call us via these digits. And in this class, we'll be dwelling or treating linear equations on algebra. So let's go ahead into the class. Okay. According to the notes, we defined a linear equation as a straight line or a straight line equation in which the highest power of the variable is 1. Okay, I know you're familiar with an equation of this form. Okay, let's say s squared plus 6x plus 5. Okay, this is a quadratic equation. So when you have equations that has power, we call them polynomial equations or polynomial functions. Okay, but in this class, we're going to be dwelling on what is it called? Equations which the highest power of the variables are just 1. For instance, where we have x plus 3 is equal to 8. The highest power of the variable here is just 1. I think in our index class, we have a work done on this. Okay, so let's continue. In this equation, we have x, right? This x is called a variable. So I think I talked about it a little bit on the note. So a variable or unknown. So we'll have to solve for it. Okay, and these ones are the constants. Okay, that's for 3 and 8. While here we'll have a variable. Okay. Then we also have a coefficient. So a coefficient is a number that is written together with a variable, and a coefficient is never same with these other numbers you have here. They are never same with constants. No, they are quite different. So oftentimes I advise people or students while solving to consider this coefficient as, let me say, a multiplier of the variable. I can also use them in that sense as this. Instead of you saying 2y, you can also imply y plus y, which will give you back same, which is 2y, right? So let's consider this as two variables combining or summing up to give us this, not just as a single entity. In essence, I'm just trying to say that these two, which is the coefficient here, is never same with these constants that we have here. So let's go ahead and solve some questions or go into the class and have fun. Okay, so before that, just one more thing. Let's go through the steps involved. One will have collecting of like terms, but I just called it, I wrote it as collecting of like terms. I wrote collecting like terms or collect like terms. That is just the kind of wordings we'll be using here, and each of the processes I take, I'll make sure I explain it to you very well. So we'll have to cross multiply, but this is basically when we'll have fractions and we'll have to divide both sides with the coefficient of variables. I'm going to talk about that in the course of the class, and then multiplying or dividing through with a common number. So let's continue. Okay, so we'll have exercise, and then we'll have about 5 questions. Let's go ahead and solve these questions. Okay, the first one says x, right? X plus 3 equal to 5. This question now is very much simple. Before you solve it, I want you to solve this. Before you go ahead to attempt it, I want you to solve this intuitively. Okay, let's ask ourselves this simple question: what number do we have to add to 3 to give us 5? I think if you just think a little bit, you figure it out, and that's 2, right? Okay, so 2 plus 3 gives us 5. Makes sense. But now, in cases when we have something like 3 million, or let's say 365 plus 3 equals to 786, you might not be able to figure that out. So that's why we'll have a specific rules or steps which we can use to arrive at a definite answer. So just like I explained, this is the variable we are meant to solve for it, and we've already done that, which is 2, right? So let's solve for it mathematically and check if it's going to still make sense with what we just said. Okay, let's continue. So x is a variable and 3 is a number, 5 is a number, therefore they can never add. Variable number, no, that's not possible. So we have to collect like terms. Please observe the first step you're taking: collect like terms. Okay, Like terms are just numbers that are related, or let's say kind of, I use the word homogeneous, that are just let me say alike. That's another word you can use for it. So right here, x is a variable, so it's an alphabet, while 3 and 5 are numeric values, so they are related somehow, or they are alike. Therefore, let's combine them. So moving 3 over here, we're going to have x equal to 5 has been here, right? Yes. So 3 is meant to come over here, but now mind you, whenever a number crosses the equality sign, the sign of that number changes. So the sign of 3 here was positive, now it's going to change to negative, so negative 3, and then we'll have x is equal to 2. Did that make sense with what we said earlier? Yes, it did. It made sense with what we said earlier. Okay, so let's go for the next question and solve for it. Okay, right here we'll have so we just solved our x is standing alone. So what we are meant to do is to isolate x, or making the x to stand alone. So next question, the second one says y minus 2 is equal to 4. Okay, so I think right here y can never subtract 2, so let's decollect like them. So the question is asking us, what number can we remove? Okay, what number can we remove 2 from to give us 4? What can we remove 2 from to give us 4? That might be very much difficult to figure out if you're not good with word problems, but the answer is 6, because if I remove 2 from 6, it's going to give me 4, right? So it makes sense. Let's go ahead and solve this. So the right approach is to collect like terms. Let's collect like terms. If you watch where we write our steps down and we make sure we do the right thing. So right here we have y is going to be equal to 4. 4 has been here, then coming over, the sign will change, so it's no longer going to be minus, it's going to be positive 2. Then we'll have y is equal to 4 plus 2 gives us 6, and that makes sense, because when we subtract 2 from 6, we are going to end up with 4. Making sense? Okay, let's continue with the next question, the third one. Now I want you to pay attention, be very much careful for this third question, because it has a variable and then a coefficient. Okay, so we'll have a variable which is m, and then we also have a coefficient which is 2, so be careful about that. Okay, we want to isolate m, right? So what we have to do is to start from, we have to remove the numbers that are farther away from m. So the farthest number from m is 10 followed by 4, right? Before we get the coefficient, which is 2. So let's start from 10. 10 is already on the right hand side of the equation, so we're not working on 10, so we have to move 4 over, right? So we apply the necessary process, collects like terms, and then we are going to have 2m is equal to 10, the sign changes, right? Minus 4, please don't forget that. And then 2m is equal to 10 minus 4 is 6. What's the next step? Dividing. Okay, yes, because we have a coefficient and a variable, for us to clear this coefficient, we have to divide both sides by the coefficient of our variable, and in this case the coefficient of our variable here is 2, right? Okay, so let's say divide both sides by 2. Now I want you to take note of something. We are not using 2 because we prefer 2 or 2 is more suitable. We are using 2 because 2 is actually the coefficient of the variable in this particular case. So 2m equal to 6 dividing both sides by 2, right? Okay, so we are dividing both sides by 2. 2 divided by 2 is 1, or they cancel out, so m stands alone, and 1 times m is still m, so the m stands alone. And 2 divided by 6 is 3, right? Okay, and that's 3. Okay, I want us to check our answer. Let's check this particular answer. Let's check to ensure that we solved correctly. So let's check. The initial equation said 2m plus 4, right? So let's leave this other side and to know if it will balance out. So let's continue here. So we are having 2, and our m is what? 3, right? We've solved for m to be 3, so observe that m is 3. So we are going to substitute for the value of m right here now. So we don't wish to have m again, we are going to have 3 because we've solved for m and m was 3. So 2 times 3, remember in mathematics whenever you have brackets it implies multiplication, so 2 times 3 is 6, and then let's add it to 4. Okay, so 6 plus 4 is giving us 10, so that makes sense with what we had initially. So this, what we had here, is same with what we had here, which means we actually solved correctly. Okay, let's go for the next question. It says 5k minus 5 is equal to 5. Okay, 5k, okay, minus 5 is equal to 5. So same process, we have to collect like terms. Collect like terms. So we are going to have 5k is equal to 5. Please don't make the mistake of not changing the sign. So we're going to have plus 5, not minus 5 again. So 5k is equal to 5 plus 5 is 10. So we have to divide both sides by what? By 5. Why are we dividing? Because our variable have a coefficient. But in cases like in this one where our variable did not have a coefficient, we just stopped, right? We are done. When we go to this point, we are done, we'll go to that point. But right here, I want you to know that our variables are having coefficients, so we have to divide by the coefficient for us to have our variable standing alone. Don't know if you get. So divide both sides by 5 because 5 is the coefficient there. So divide both sides by 5. Okay, so 5k divided by 5 is equal to 10 divided by 5. Okay, so 5 divided by 5, so the 5's cancel out and then we are left with k, and then 5 here is 1. 5 divided by 10 divided by 5 is going to give us 2, right? Okay, so we are done with that. I hope this was clear or it made sense to you. Okay, let's solve the last question. The final question says 4 brackets f minus 2 is equal to 8, right? Okay, let's check it to confirm. Yeah, 4 brackets f minus 2 is equal to 8. Okay, so let's continue. Now remember we have a parenthesis here, so I think let me highlight it. So we have a parenthesis here, and whenever you have your brackets in mathematics, what does it tell you? It implies multiplication. And please check out on the video, on the previous video, which talks about expansion. So we'll have to expand the left hand side right now. Okay, that's the approach you can apply to this. So let's say expand left hand side. No, this is the left hand side and this is the right hand side. So on the right hand side we just have it. So let's expand it, and expanding it simply means, please take a look at this point, f minus 2 is equal to 8. It simply means using this to distribute inside the bracket. So I meant to distribute this. So let's do that. So we'll have 4 multiplied by f, and then positive 4, right? Still positive 4 plus 4 multiplied by negative 2. Please be mindful, I kept my signs. Positive 4 multiplied by what? Positive f. Positive 4 multiplied by negative 2 and equal to 8. So let's use our knowledge of multiplying signs. 4 multiplied by f will give us 4f, and then 4 multiplied by negative 2, different signs, right, gives us negative. So negative 8 is equal to 8. Okay, the next step here now is 4f minus 8 can never work. So what do? We have to collect like terms right here. So we are collecting like terms. This question looks a little bit more tasking or challenging, but I assure you that if you take the necessary approach, you definitely get it. So we have 4f is equal to 8 plus 8. Remember, it's crossing the equality sign, so the sign has to also change. Yes, sign have to also change, right? Okay, 4f is equal to 8 plus 8 is 16. So what is the next step? Because our f has a coefficient, we have to divide both sides by that coefficient. So divide both sides by 4, right? Let's continue here. So have that 4f divided by 4, okay, is equal to 16 divided by 4. Okay, right here the 4's cancel out and f is standing alone. 16 divided by 4 is 4, and that is our final answer. Okay, now we are in the next phase of this class where we will be dealing with linear equations with fractions. Okay, so these are linear equations, but just that they have fractions, and then we're going to solve them. Let's go ahead. The first one says 1 over 2x is equal to 6 over 4. Okay, so 1 multiplied by x is same thing as x, right? So just x over 2 is equal to 6 over 4. Please watch the way I'm taking my time to make sure I simplify everything. Now remember the process, the step that said cross multiply when you have fractions. Now we have fractions, therefore we have to cross multiply. So let's cross multiply. Cross multiply, we are going to have x multiplied by 4 is equal to 2 multiplied by 6. X times 4 is 4x, right? And then 2 multiplied by 6 is 12. Now we've gotten to the step here. We'll have a variable, a coefficient, and a constant on the other side. So what do? We apply same approach. We take same approach, or we apply same method or concept, dividing both sides by 4, right? Why are we using 4? Because 4 is the coefficient of the variable. So divide both sides by 4. So we are going to have 4x, okay, sorry, 4x divided by 4 is equal to 12 over 4. Let's cancel out the 4's, and then our x stands alone. 12 divided by 4 is 3, right? And that's our final answer. Okay. Now these are also a branch of fraction, which I call equivalent fractions. So if you have a basic knowledge of equivalent fractions, I know you're going to be cool with this. Okay, let's continue. The second one, it says for number 2, 3 over 2 is equal to 2 plus 1 over x. So let's make this one easy. 2 plus 1 can add, right? So because they can add, let's just simplify that one. So we'll have 3 over x. So very much simple. Right now, let's cross multiply. Okay, if we cross multiply, we're going to have... Now, while cross multiplying, you can choose to start from this. Okay, let me give you an instance. You can choose to multiply this way, or you can also choose to multiply this way. Any method you are using is just correct, but make sure you are actually cross multiplying. So the word explains the action, cross multiply. So anyway is just correct, or that's cool. So let's go for 3 multiplied by x. I like to have my variables first, and then the next one is what? 2 multiplied by 3, or you can as well write 3 multiplied by 2. That's still cool. So 3 multiplied by x is 3x, and then we'll have 2 times 3, that's giving us 6. Now it boils down to same thing. We have to divide both sides by 3, sorry, because that's the coefficient of the variable. Divide both, okay, both sides by 3. So we have 3x divided by 3 is equal to 6 over 3. Okay, let's cancel them, and then x is 6 divided by 3 is 2. And that's our final answer. For the third one, we'll have 5k over 4 equal to 10 over 2. So let's do it here. Okay. Now we have to cross multiply, right? So let's cross multiply. This is the third one. Doing that, we are going to have 5k multiplied by 2 is equal to 10 multiplied by 4. So 5 times 2 is 10, right? So 10k. Now, whenever you have a variable and a number, they can multiply, yeah, but they cannot add or subtract. Okay, so let's continue. 10 multiplied by 4 is 40. Dividing both sides by 10, right? So divide both sides by the number 10. So 10k divided by 10 is equal to 40 over 10. Cancel out the 10s. Okay, so 0 can cancel 0, very simple, and then k is giving us 4, because 40 divided by 10 is just 4. Okay, for question 4, we have 3 plus y over 4 is equal to 3 over 2. Now 3 plus y cannot add, so let's just go ahead and cross multiply. Hope you know why we didn't add them, because we have a variable and a numeric value, so they cannot add. So we are going to have 2 brackets 3 plus y, and then 4 multiplied by 3. Don't be confused. I used 2 to multiply these numbers, but because they are 2, we have two quantities or two numbers here. I had to put it in a parenthesis or bracket so that I don't get confused. While here I can actually multiply straight. Now we are not just going to multiply them, we have to distribute these 2. So 2 will multiply 3 and as well multiply y. So right here we'll have 2 multiplied by 3 plus 2 multiplied by y, and then 4 multiplied by 3 is what? 12. 2 multiplied by 3 is 6 plus 2 multiplied by y is just 2y. So we'll have 2y and equal to 12. So we'll have 2y. 6 plus 2y is equal to 12. Now what do? We can collect like terms here. Please look out for this very well. Collect like terms. We are going to be left with 2y is equal to 12 minus 6, right? Because this 6 is moving over the numeric values while the 2y remains here. Then 2y is equal 12 minus 6 is 6. Let's continue from this point. So we are going to be left with 2y is equal to 6. What do? We divide both sides by the coefficient of y, which is 2. So 2y is equal to 6, dividing both sides by 2. Okay. So the 2's cancel out, and then y is equal to 3. And that's the final answer. Wow, so we are done. I want you to try these questions on your own. Please make sure you try them before you check out for the answer. The answer is just immediately after this particular slide. So what you have to do is pause the video, solve the question, then play it. The answer will just display. Yeah, but I want you to make sure you do this on your own, and I would also love it if you can make a perfect score. Wish you the best of luck. So look at the answers. Wow, so these are the answers. I want you to go through your work right now, and while solving, make sure you write your work down so that you can actually spot out errors or mistake or whatever. Okay, so let's continue. Wow, we are done. Wow, so quick or whatever. Wow, thank you so much for being a part of this class. This is Mr. Johnson Math and Science class. I really appreciate. We got you covered for your math, your exam prep, your NECO, WAEC jam, and all that. So have a good time, and thank you for being a part of us. I really appreciate it.